Exercise 12.3. We start with question 1. So question 1a says calculate the length of diagonal AB in each of the following quadrilaterals, correct to 2 decimal places when necessary. Alright, now we have a trapezium over here and we need to calculate this diagonal AB. So this one is pretty easy because first of all, we are given that this is a 90-degree angle, so I can state that ADB is equal to 90 degrees, and my reason is given. Then I've got, then I can use Pythagoras to solve for AB. So in Pythagoras, the long side, AB squared, is equal to the other two short sides squared. So that would be AD squared plus DB squared. And my reason is Theorem of Pythagoras. So basically now I can just substitute my known values. So AB is equal to, or AB squared is equal to, now AD is 10 squared plus 24 squared. And then AB will be equal to the square root of 10 squared plus 24 squared. So if we work that out, we have the square root of 10 squared, or 100, plus 24 squared. So this will give me 26. And we are working in meters, so we have to say 26 meters. Then question 1b, so once again, we're going to calculate the diagonal. This is a rectangle, and in a rectangle it's already given that this angles, all angles are 90 degrees. So I'm just going to go ahead and I'm going to solve for AB, and once again just with Theorem of Pythagoras, so we can just state that AB squared is equal to AT squared plus BT squared, right? AT, BT. So my reason is Theorem of Pythagoras, and substituting in our known values, we've got AT being 16 squared plus BT is 12 squared. So AB is then equal to the square root of 16 squared plus 12 squared. And that would be the square root of 16 squared plus 12 squared. So this is equal to 20. And we are working with centimeters. Question 1c. Now we have to calculate the diagonal of a square. So the first thing we do, we've got our statement and reason, of course. And then since this is a square, we know that BS is equal to AS. So I'm going to write that down. BS is equal to AS. My reason is sides of a square are equal. So sides of square is equal. And then therefore I can say that BS will be equal to 25 centimeters as well. So now we just once again, and since we know this is 90-degree angle, we once again can use Pythagoras to find AB. So AB squared is equal to BS squared plus SA squared, or AS squared. Theorem of Pythagoras, right? And then we substitute in our known values. So BS, so that's just both our 25 squared plus 25 squared. So AB is equal to the square root of 25 squared plus 25 squared. So working that out, that gives us Now the question states to 2 decimal places. So this is to simple assert, that's 25 and square root of 2, but to 2 decimal places, we just press the SD button, then that gives us 35,36. So that's 35,36 and centimeters. Here we have question 1D. Now we need to calculate AB. So statement and reason. So before we can get to AB, the only thing we have here is this AQ, and what we also need is a right-angled triangle to find AB. So where do I see? I see a right-angled triangle over here, and I also see a bigger one over here. If I do this. So if I actually know this length over here, then I would be able to calculate AB using Pythagoras. So what I'm going to do is, see, we're working now in a parallelogram. So what do we know about a parallelogram? We know that the opposite sides are equal. That would tell us that PB would be equal to AQ. And my reason is opposite sides of parallelogram equal. Alright, so therefore PB is equal to 9 centimeters. Alright, then if this is 9, then RB, so RB is equal to RP plus PB, and that is equal to 3 plus 9, which is equal to 12 centimeters. Now we're in the position to use Pythagoras in this bigger triangle. So we have AB squared is equal to the short side RA squared plus RB squared. So this is Theorem of Pythagoras. And then we substitute in unknown values. So this is then RA is 5 squared plus 12 squared. And AB is therefore equal to the square root of 25 plus 144. So that gives us the square root of 25 plus 144, and that's 13 centimeters. Then question 1E, calculate the length of the diagonal of AB in the rhombus. So we have that RO is 12, AM is 20. So we have our statement and reason, and we need to find AB. So what do we know about a rhombus? We do know that the diagonals bisect each other at a 90-degree triangle. We also know since they bisect each other, that these are equal to each other. And yes, so if I can solve for this side, and since this is a 90-degree angle, right, we've got this right angle triangle, and we know that since this is equal to each other, this is also 12. So see, we've got a right angle triangle here with one unknown side. So this means we can actually solve for OA, and since they bisect each other, we can double OA and get AB. So let's get started with that. So the first thing we said was that OM will be equal to RO, and my reason for that is diagonals of rhombus bisect. Okay, that means that OM will be equal to 12 centimeters. Now, I need to state that AOM is equal to 90 degrees. And why? Because diagonals of rhombus are perpendicular. Okay. And then I can use Pythagoras. So remember, it's the long side, or if I want to find the short side, so I want OM squared. I take my long side, AM squared, and I subtract my other short side from it squared, OM squared. So let's substitute in our values. We've got, oh yes, and of course say Theorem of Pythagoras. Then I've got OM squared. AM is equal to what? AM is equal to 20 minus OM, which is 12. So, wait, this doesn't make sense. AO, this should be the short side. I'm looking for AO. So this is AO. I'm solving AO. Okay, that looks terrible. Alright, then AO is equal to the square root of 20 squared minus 12 squared. And let's do that on the calculator. So 20 squared minus 12 squared is equal to 16. And we are working with centimeters. Now, since OA is equal to, or AO is equal to OB, once again, this is the diagonals of rhombus bisect. We know that OB, or we can state that therefore AB is equal to 32 centimeters. Question 1F. So in question 1F, we have a kite AXBY with AY being 10 and BY 17. And then we've got XY, which is this diagonal over here. That one is equal to 16 centimeters. So let's just have a look at what we're going to do. What do we know about a kite? We know that this is equal to 90 degrees. We also know that our longer diagonal bisects our shorter diagonal, so this should be equal to that one. And immediately I can see that if this is 16, this must be 8, right? And I need to find AB. So if I split these two triangles, or this big triangle, up into two smaller right angle triangles, then I can obviously solve for OA using Pythagoras, because I've just determined what OY will be. And similarly, I can do the same with OB, solving that using Pythagoras. So let's get started with that. First of all, we saw that XO is equal to OY. And our reason is the diagonal of of kite bisects short diagonal. Alright, so that means that OY will be equal to 8 centimeters. Okay, now let's move on to the smaller triangle first. We have, using Theorem of Pythagoras, we need to find one of the shorter sides. So we're going to say OA squared is equal to my long side, AY squared, minus my other short side, OY squared. So that is the Theorem of Pythagoras. And substituting in my known values, I've got OA squared is equal to AY. So AY is 10 squared minus OY we saw was 8 squared. And then the OA will be the square root of 10 squared minus 8 squared. So this is going to be equal to, or let's just put that on the calculator, just 100 minus, so this is then 100 minus 64, so this gives me 6 centimeters. Alright, and then moving on to the bigger triangle, we've got OB, also a short side. OB squared is equal to my long side BY squared minus my other short side OY squared. Alright, so now OB squared is equal to BY, which is 17 squared minus 8 squared, and OB is equal to the square root of 17 squared minus 8 squared. So this is equal to square root of 17 squared minus 8 squared. This is 15. Okay, I just forgot to say Theorem of Pythagoras. Then we can state that AB is equal to OA plus OB, and then that would be equal to 15 centimeters plus 6, so 15 plus 6, and that gives us 21 centimeters. Right, so now we can start with question 2. Now question 2a, calculate the lengths of the unknown sides marked by lowercase letters. Leave your answers in insert form where applicable. Now we need to find A and B. So A is pretty straightforward. We've got this looks like a rectangle where we've got the opposite sides equal. So we know that A is equal to 40, and my reason is given because it's given that this side is equal to that side. And then I need to find B. So once again, we are in a right angle triangle, so I need to just use Theorem of Pythagoras, and B is a shorter side, so I'm going to say BC squared is equal to my long side DB squared minus my other short side DC squared. Theorem of Pythagoras. Then BC squared is equal to, my short side was 50 squared minus 40 squared. So BC is equal to the square root of 50 squared minus 40 squared, and that is equal to 50 squared minus 40 squared. So that's equal to 30. And we are working, we're not given any units, so you can just basically say 30 units. Question 2b. So in this question, we have once again an A and a B value to solve for. So let's start with A. We have our statement and reason. Now, as you can see, this is a right angle triangle, and this is just the long side. We've got the other two sides, so this is quite easy. We know that DB squared is equal to the two short sides added together, so that's AD squared plus AB squared. Right, so reason, Theorem of Pythagoras, and then DB squared is equal to 6 squared plus 8 squared. So DB is equal to the square root. This is 36 plus 64, and together they give us 100. So the square root of 100 is just 10. So this is 10. And then from there on, if this is 10, and we need to find B, we see that this is also a right angle triangle, and this is also the long side of the right angle triangle. So once again, I'm just going to say DC squared is equal to DB squared plus BC squared. Theorem of Pythagoras. Okay, substitute in the known values, dc squared, so db is 10 plus 7 squared equals to, so dc equals to the square root of 100 plus 49, and that is equal to the square root of 149. So this is just the square root of 149, but we want it in 2 decimal places, so that's going to give us 12,21. So that's 12,21. And once again, just say units. Question 2c. We have an a and a b to solve for once again. We have our statement and reason. So here we have also very easy again, this side equal to that side. So a is equal to 8 units, and it's given. Then we need b. So this is these guys, they bisect each other, or not bisect, but they cut at 90 degrees. Now it could be that they bisect, because if I look at this looks like a rhombus, because all sides are equal, it seems. So that means, and we see that this is at 90 degrees, so that does mean that these bisect each other right here and here. So we know, since this is in a right angle triangle, we've got our long side and we've got our other short side. So MQ, which is B, so MQ squared will then be, since it's one of the shorter sides, my longer side MN squared minus my other short side NQ squared. Theorem of Pythagoras. Right. Then substituting my known values, since this is b squared, is equal to long side 8 squared minus 7 squared. So b is equal to the square root of 8 squared minus 7 squared, and that is equal to 8 squared minus 7 squared. So this is 15, square root of 15, and to 2 decimal places, that would be 3,87. 3,87, and we're working just with the units. So question 2D. Now we have A, B, and C to solve for. So once again, statement and reason. Okay, this seems quite easy because we are already given that all sides are equal. So this is a square. We know that A is equal to 4 units, given. We know that B is equal to 4 units, given. Then C, and since this is also a right angle triangle, we can just state that SRQ is equal to 90 degrees, since it's not shown in the diagram. We can just say that it is the angles of a square then we can say that SQ squared is equal to SR squared plus QR squared. Why? Because of the theorem of Pythagoras. Okay, so now substituting our known value, C squared will be equal to 4 squared plus 4 squared, and C is then the square root of 32. So then we can just put that on the calculator to 2 decimal places. So the square root of 32 is equal to 4 square root of 2 to 2 decimal places. It's 5,66. So 5,66 units. Right, so let's get started with question 3. So question 3a, calculate the values of the lowercase letters in each of the following diagrams. Okay, so this one is quite nice. I like these type of questions where they have a bunch of angles that contain x, and we need to find the relationship between these angles in terms of x. So basically what that means is we know that all the angles of a quadrilateral add up to 360. So I can just say each of these angles added together equal to 360 and solve for x. So let's start with u. We've got 143 degrees plus x plus 25 plus 2x plus 90 degrees, and that would equal to 360 degrees. And my reason is angles of a quadrilateral. Alright, and then we solve for x. So here we have, let's just put all our x's together and take all our constants to the other side. So 360 minus 143 minus 25 minus 90 degrees. So this is going to be 3x is equal to 360 minus 143 minus 25 minus 90 gives us 102. Now dividing both sides by 3, we have x equals to 34. And that should be 34 degrees. Question 3b, calculate the values of the lowercase letters in each of the following diagrams. All right, A, B, and C. Now we see that with this, both opposite sides are parallel to each other. This means it is a parallelogram. And first of all, since these two are, let's start with A, and since these two are inside two parallel lines, this will be co-interior angles. So I know that they add up to 180. So A plus 65 is equal to 180 degrees. And the reason is co-interior angles. And the lines that are parallel are AB being parallel to DC. So A, therefore, is equal to 180 minus 65. So this is 180 minus 65, and that gives me 115 degrees. Okay, B. Now, I can use co-interior angles, but it's much easier just to say that B is equal to 65 because it's the opposite angles of a parallelogram are equal. So B is equal to 65 degrees, opposite angles of parallelogram equal. And then finally for C, C is also just equal to A. So C is just equal to 115 degrees. And once again, opposite angles of parallelogram equal. Question 1c. Here we have A, B, C, and D to solve. Now, all of these are pretty easy. And the first one, A, is just corresponding angles. Since we are working with parallel lines here, so we can simply say that A is equal to 75 degrees. Corresponding angles, and I've got ED is parallel to BC. And then for B, B and A are co-interior angles. So what I'm going to do is those two add up to 180 degrees. So A plus, or let's say B plus 75 degrees is equal to 180 degrees. Since these two are co-interior, we've got co-interior angles. And now the parallel lines are AB and DC. So AB is parallel to DC. So B is equal to 180 minus 75. So that's just 105 degrees. Right, moving on. We have a B and then C. Now C, this forms a Z with A right there. So they are equal to each other, being alternate angles. So C is equal to A, which is 75 degrees. And my reason, alternate angles where AB is parallel to DC. Okay, then finally we've got D. Now D also is also alternate angle with this angle over here. So this is equal to each other. Therefore, actually they also just equal. So therefore D is equal to 75 degrees, alternate angles, where AB is parallel to DC. So question 3D. This looks like a kite. And what do we know about a kite? We do know that the angles that are opposite each other are equal, are not these two angles, only those angles that are between the unequal sides. So this angle is equal to this angle. So W is equal to 100 degrees. And my reason is opposite angles of a kite. Equal. Right. Then remember, kite's also quadrilateral, so that means that all the angles will add up to 360. So x plus the 100 plus this 78 plus that 100 all will equal to 360 degrees. My reason is angles of a quadrilateral. And then solving for x is quite simple. We just take everything over to the other side. So 360 degrees minus 100 minus 100 minus 78. And that's equal to 360 minus 200 minus 78. 82 degrees. Question 3E. Now we need to calculate x, y, and z. And once again, we are working in a kite. So starting with x, I can see, if I look at this triangle alone, the first thing I see is we have these two sides being equal. So that means that this and this is equal. And if I have that this is also 74 degrees, that's easy to solve for x because it's angles in a triangle. So starting off with that, we can say that AD is equal to AB. So that's a given. Then it means that D1, angle D1 is equal to 74 degrees, and that is equal angles, or angles opposite equal sides. And therefore x plus 74 degrees plus 74 degrees is equal to 180 degrees. So this is angles of a triangle. And then x is equal to 180 minus 74 minus 74. So x will then be equal to 180 minus 74 minus 74. So this is 32 degrees. Okay, now moving on to y. What do we see? We see that these two are equal, but we don't know that one yet, although we can find it quite easily because we've got these angles on a triangle. So once I've got this angle, I know what y would be. And to start off with, we can say that D2, angle D2 plus 68 degrees plus 74 degrees is equal to 180 degrees. And my reason is angles on a straight line. So solving for D2, we have 180 minus 68 minus 74. That's 38 degrees. Now, since DC is equal to BC, which is given, we know that y is equal to 38 degrees because it's angles opposite equal sides. Since these two sides are equal, these two angles opposite them will also be equal. Alright, and then finally, since we know both of these angles are 38 degrees, it's easy to find z by angles of a triangle. So z plus 38 degrees plus 38 degrees equals to 180 degrees, angles of a triangle. And then solving for z, we simply say 180 minus 38 twice. So 180 minus 38 minus 38 is equal to 104 degrees. Question 3F. So here we have A, B, C, D, and E to solve. And starting with A, we can see that in this bigger triangle, A is just one of the angles, and we know the other two angles. So that means that A plus 68 degrees plus 50 degrees will be equal to 180 degrees. Reason, angles of a triangle. So A will be equal to 180 degrees minus 68 minus 50, and that would give us 62 degrees. Right, now B. Now B and A are co-interior angles, so that means that B plus A will be equal to 180 degrees. So my reason is co-interior angles, and my parallel lines are LM being parallel to BN. Right, so B is equal to 180 minus 62. So that's 118 degrees. Then C, now since this smaller quadrilateral is a parallelogram, since the opposite sides are parallel. Now we could have just used co-interior, but it's just going to be much easier to say that C is equal to A. So that's C equal to 62 degrees, simply, because of opposite sides, opposite angles of a parallelogram. Okay, then for D, now once again D I can do exactly the same. I can say that D is equal to B, 118. Also opposite angles of parallelogram. And then finally E. Now E, we've got a couple of options here. we can use angles on a straight line, but what's easiest? The easiest one will just be to say that E is equal to C because of alternate angles. So E is equal to, what was C? 62 degrees. That's alternate angles. Parallel lines are LM being parallel to BC. 3G. This one's also pretty straightforward. We see that both of these are parallel, and also MP parallel to AR. So that means we are working once again in a parallelogram, making the opposite sides equal to each other. So I'm just going to say simply 3x minus 10 equals to 2x plus 20. My reason is opposite angles of parallelogram, and then solve for x. So all my terms containing x comes to the left hand side, changing the sign when I bring the terms over. So 20 plus 10. So this is then x equal to 30. That was very easy. Question 3H. Now over here we've got MPQN, if that is the MNOPQ, yeah, MNOP and then Q. So starting off, here we have we see that all of these are equal. Now this looks like a rhombus, and what else we know about a rhombus is that the opposite sides are also parallel to each other. So that, and then over there, those two being parallel. So in finding M, we can just use alternate angles, since this makes a N or a Z. So M is equal to 42 degrees, and that's alternate angles. So we've got RH being parallel to MO. Alright, so now we need to find N. And if we look at this triangle over here, this is this side being equal to this side makes this an isosceles triangle. So that means these two angles are equal. And that means that N, okay, let's just first state that RH is equal to RM, that it is given. So therefore, we've got N equal to 42 degrees, and our reason is that it is angles opposite equal sides. Okay, and now finally we can solve for P. P is equal to, if we have three angles in a triangle with one unknown, easy to solve. We just have we know that they add up to 180. We have P plus 42 degrees plus 42 degrees is equal to 180 degrees. So we've got angles of a triangle, and then P is equal to 180 minus 42 minus 42. So this is equal to 96 degrees. Okay, then Q. Now the opposite angles of a rhombus are also equal. So we can just state that Q will be equal to 96 degrees. Opposite angles of rhombus equal. Question 3I. Calculate the values of the lowercase letters. Right, so here we have M and N to calculate. And start by writing statement and reason. So starting with M, we see that it's in this triangle, and if we look at what are we working with, we can see that we're working with a rectangle because this is a right angle, and we see that the opposite sides are also equal. So what else do we know from a rectangle is that the diagonals are equal. So Ln is equal to MP, and they bisect. So that means that this is equal to OP, and LO will also be equal to ON, and also equal to OM and OP. Now that means that this triangle in which M lies is an isosceles triangle. So that means that this would also then be equal to M. And we know these two angles are vertically opposite. So that would be easy to solve, because if we have 52 over here, then we only have one unknown. So we can say that these three added together will give me 180 degrees. So to start off, I'm going to say that O1 is equal to 52 degrees, and my reason is vertically opposite angles. Then I can state that OM is equal to ON, and my reason is that the diagonals of rectangle bisect they actually equal and bisect and equal. Alright, so now I can solve for M by saying that M plus N1, or actually let's start by saying that M is equal to N1, and my reason is equal angles opposite equal sides. Okay, and then I can say that M plus N1 plus 52 degrees is equal to 180 degrees, angles of a triangle. And then M, since M is equal to N1, I can replace that. That's just M plus 52 degrees equals to 180 degrees. So 2M is then equal to 180 minus 52. So this is 180 minus 52 gives me 128. And then if I divide both sides by 2, I get M is equal to 64 degrees. Right, so now for N, we know that this is a right angle. So we can state that, we can say that PNM is 90 degrees, just because they didn't give it to us, we can write it down. And our reason is angles of a rectangle and then we can say that M plus, or actually N1 plus N plus M, or N1 is equal to 90. So that means that N is equal to, or N plus 64, since N1 is equal to M, is equal to 90, and therefore N is equal to 90 minus 64. So 90 minus 64. And that gives us 26 degrees. Question 3J. Here we have R, Q, S, T, and U to solve. So we can start off by looking what are we working with. And here we see that all sides are equal. So this means it must be a rhombus, because we're not given that it's a 90 degrees. So this looks like a rhombus, and with a rhombus we know that the diagonals bisect perpendicularly. So this is going to be 90 degrees. So I can immediately say that Q is equal to 90 degrees. And my reason for that is the diagonals of rhombus bisect perpendicularly. Alright, and then next one to solve for, I can see that if I'm working in this triangle over here, it means that the only angle that's unknown is this R. So I can use interior angles of a triangle to solve for R. I can say that r plus 25 degrees plus 90 degrees will be equal to 180 degrees. And that's simply angles of a triangle. So r will then be equal to 180 minus, got 180 minus 25 minus 90. So that gives me 65 degrees. Okay, now next, what do we also know about a rhombus is the opposite sides are also parallel. So if I want to find S, then S will be an alternate angle to R. So that means that they are equal. So that means that S is also equal to 65 degrees, alternate angles. And the lines that are parallel are LM being parallel to PN. Okay, and then furthermore, if we need to find, now we need to find T and U. So what else do we know about a rhombus? We know that a rhombus bisects its angle. So that means that this angle will be equal to this angle. So that means that T is equal to 25 degrees. And my reason for that is the diagonals of a rhombus bisects the angle. So diagonals of rhombus bisects angles. Okay, then we need to find U. Now U, the opposite angles of a diagonal are also equal. Let's just make these 2. Then this U will be equal to both of these together. So U will be equal to 50 degrees. And our reason is opposite angles of rhombus equal. Then for question 3K, calculate the values of the lowercase letters. So here we have A and B. Now we can see that this is a square, since we have this 90 degree and we have that these 3 sides are equal. We can also know that this one will also therefore be equal. So I can immediately state that B will be equal to 90 degrees. And my reason for that is angles of a square Alright, so now in finding A, we also know that this, okay, since this is given, PQ is equal to QS, so PQ is equal to QS, it's given. We can see that this is an isosceles triangle. So that means that this will also be equal to A. So that means that I can say that PSQ is equal to A. Angles opposite equal sides. And then I can use interior angles of a triangle. So I can say that A plus 90 degrees is equal to 180 degrees, angles of a triangle. And then 2A will be equal to 180 minus 90, so that's 90 degrees. And then I divide the sides by 2, so A is equal to 45 degrees. And then for 3L, here we have quite a few to calculate, but I don't think it's that difficult. The key is that ABC is a equilateral triangle. So what does that tell you about the sides? All the sides are equal, A, B, BC and CA. And what does it tell you about the angles? All the angles equal to 60 degrees. So to start off, immediately I can see, or also what's given is that these lines are parallel. So we need to look out for those 3 one of those three statements, the corresponding alternate or co-interior angles. I think we might use those most in this question. So first of all, I can see that K will also be equal to 60 because of the corresponding angles over here. So K is equal to 60 degrees. We have corresponding angles, and my lines that are parallel are BP is parallel to QR. Right, now next up we can solve for H because we've got angles on a straight line, so that's quite simple. So H plus 60 is equal to 180 degrees, angles on a straight line. So therefore H will be equal to 120 degrees. If I subtract 60 from 180, then we can find G quite easily, because if these lines are parallel and these lines are parallel, that means this is a parallelogram. And in a parallelogram, the opposite angles are equal. So therefore, G is equal to 120 degrees, opposite angles of parallelogram. Right, and then F is easy to find because we've got the other two angles of the parallelogram. So F is equal to 60 degrees, also opposite angles of parallelogram. Alright, then we've got M, but M is also a corresponding angle to 60 degrees. So M will then be equal to 60 corresponding angles. And the lines that are perpendicular are PQ being, not perpendicular, parallel to BC. Okay, then we still need to find P. So we can basically use the angles of a triangle. So we know that P plus 60 plus equals 180 degrees, angles of a triangle. And then we know that P will also be equal to 60 degrees.
And that's the end.